Hey everyone, today our topic will be on exploring exponents and the power function in Excel. In Excel, the power function is used to raise a number to a specified power. So the basic syntax for the power function is like here, the number is the base you want to raise the power, and this is the base number, and the power is the exponent to which the base number is raised. For example, these are the exponent, okay? 10 to the power of 6, 10 to the power of 9, 10 to the power of 12, 10 to the power of 15, 10 to the power of 18, etc., etc. So what I'm going to do is I'm going to show you the large number form of this. So 10 to the power of 6, that means it has 6 zeros behind the 1. So it will be like this, 10 to the power 10 to the power of 6. So there will be 6 zeros, and this will be million. Okay. And if you're going to use the power function, it would look like this, equal sign power. There are two things here. One is the number, and the other is the power. So they're just separated by a comma. So it would be like, so the number is 10 and the power is 6. So it would be like this, 10, comma 6. Okay. So still the same, or 1 million. The next one, 10 to the power of 9 is having 9 zeros. So it would be like this. It would be like this, 10 to the power of 9. So it means there will be 9 zeros, and this would be billion. Okay. And in terms of power function, it would look like this, power, then 10, comma 9. So that's the difference. In the power function, you will just separate the base number and the power number by a comma. Okay. Unlike here, let me let me make it bigger. All right. So the next one would be raised to the power of 12. So therefore, it would be like this. Then raised to the power of 12. And that means there are 12 zeros behind the one. And this one will be trillion. Okay. And the power function would be like this. 10, then comma, and 12. 12 zeros. Therefore, it will look like this. Just like the large number form, this is trillion, 1 trillion. So the last, okay, the other one is 10 raised to the power 15. That would be quadrillion, right? So the power function would look like this. It would be 10, comma, and 15. Okay, so simple as that. Okay, I'll give you another one. 1 times 10 raised to the power of 18. So what is that? That would be 10 raised to the power of 18, and that would be quintillion. And in the power form or the power function, it would look like this, power, okay? Okay, that would be 10, comma, and 18, right? And that would be quintillion. And it would be there will be many zeros after this, but I'm gonna stop at quintillion. What's important here is that to make it shorter, okay, to look shorter, we'll just use the power function. Then we put the base number, which is 10 here, and the power number, which is the 18. But if you're gonna write like this, that would be a long form. And normally, people, especially doing reports, doing any kind of reports, any kind of uh, official report or official documentation, you would not uh, write it like this. You would, write it like this. This one, 10 to the power of 18, 10 to the power of the power, 10 to the power of something. Okay? And the function or the formula would look like this using the power. So this is the lesson for today. Our tutorial will be about using the power function. Okay? So the next sample I'm going to give you is the squaring a number. So squaring means raised to the power of 2 or squared. Okay? 10, 10 squared, 20 squared, 30 squared, so on and so forth. Could be 50 squared. What does it mean? It means uh, the 10, you multiply the 10 twice, once rather. So the answer is 100, and 20 multiplied by 20, that would be 400. Then the 30 multiplied by 30. So it multiply, okay, two numbers multiply one time only, okay, and the same number. So in the power, you're gonna write power, okay. Then you put the base number as 10, then comma, then you put the power as 2 square, then, all right. So something like that, okay. So just the difference is you got different base number, but the same power, different base number. This one is 30, same, okay. So the answer is 100, 400, 900 using the power function. So the power function is like this. So I'm going to show it to you. That's the power function. Okay, the next sample or example that I'm going to give you is the cube root. So we know already the root is equals, for example, 8 number, base number raised to the power of 1 over 3, 1/3. That would be the okay, that would be the cube root. So in cube root, what I'm gonna do in the cube root is like power again. You know already the power, right? Power, and the base number is 8, then comma, and the root number is 1 over 3. Okay, so the answer is 2, is number 2. Okay, so another example is negative exponent. Let's have a negative exponent. So it's like this. 2, again 2, the base number is 2, raised to the power of negative 3. So that would be a negative exponent, negative 3. So the answer is 0.125. So 0.125 because 2 raised to the power of negative 3 is equal to 1/8, 1 over 8. Okay. So let's say we're going to have a what you call power in a data set. Okay. In data set, let's assume you have a data set where you want to raise each value to a certain power. For example, if you have the following numbers in column A, like 2, 3, maybe 4, maybe 7, okay, maybe 12, right? Then how are you going to raised to the power of 3. So equal sign, power again, okay, the function, then you're gonna get the range which is on A26, right? So A26 raised to the power of cube, that means 3, right? In data set, okay. All I have to do is just copy it down, okay, drag it down to copy it, different example that we have in the numbers about under the A column range, okay? So that would be the power using the power uh, range, comma, then raised to the power of 3 cube, okay? Then another example I'm gonna give you is compounded growth or compound growth. I think I will call this compound growth over years, okay? What I got here in my equation, I got future value FV equals to PV, present value, times 1, enclosed in parentheses 1 plus growth rate. So the growth rate could be 3%, 4%, 5%, etc. Then the equation would be 1,000 times enclosure of parentheses 1 plus the growth rate of 5% raised to the power of 5 equals 1,000 uh, times 1.276281. That would be 1,276.28. So this is the formula that I gave you. So it would be like that. Okay. So I'm going to give you this so that you can see it. All right. So what I'm gonna do is I'm gonna get the compounded growth sales. Okay. This is over a period of times or years. So this would be the sales, for example, it's 1,000, 1,500, 2,000. Then you got 5 years, 4 years, 7 years. And then the growth in terms of interest rate is 5%, 4%, 3%. Just an example. So what would be the then what would be the power function of this? Would be like power, okay? Then tab, then 1 plus the growth rate is on C, okay, C40, and then comma, then we're gonna get the years, that one, right? And then close it, then multiply by this. Let's go back to column A, multiply by that, then enter. So that would be the answer, okay? Just put it down to get the rest of the answer, 1755, 2460. And I'll show you the formula. I'll put a single quotation mark to show you the formula. So the formula is equal power um, inside the parenthesis 1 plus C42, which is the growth rate, close parenthesis, multiplied by sales or A42. Okay, this column or this range. All right. So that would be the example of compound rate over 4 years using the power function. All right. Another example is what I'm gonna do is I'm gonna calculate the area of a circle or calculating area of a circle using formula uh, A, which is area equals pi r squared. What is r? R is radius and raised to the power of 2 or squared. So you will read it as pi, area equals pi r squared. Okay. So we know already that the pi is constant, then that would be uh, when I write this formula pi or pi, uh, in the then after is the parenthesis, then it will give you the constant number 31 for 1416. You can actually expand the decimal places. Okay, but if you're going to round it, then you can round it in two decimal places. Okay, you can round it in two decimal places or four decimal places. Okay, you can round it to 3.14 or 3.1416. Okay, so let's say I got this radius of a circle. You know, radius is really actually the distance from the middle of the circle to the edge of the circle. Okay, in the circumference. So the radius is 3, then area would be like, okay, area would be like this. Okay, all right, and then uh, that would be the radius, and then oh no, that is not correct. It would be like pi. Sorry, pi. Okay, pi multiply by power. Okay, then this is the time that we're gonna get this base number, which is the radius of a circle. Okay, then just say we know already the squared, so that would be 2 comma or rather close. Then the answer of the radius of or having a radius of 3, the answer would be 24 using the power formula. But you gotta go for pi first because that is how you get the formula of calculating the area of a circle, which is area equals pi r squared. Okay. Then what I'm gonna do is just copy it down because this is a data set, and we're doing a reference formula, or rather reference cell reference. Um, okay. So all right. So I'm gonna show you the formula would so you'll be able to see it. Okay, I'm gonna show you the formula. So the formula again is pi multiplied by power, base number, and square. Okay. Now another example that you can use the power formula in a volume sphere. Let's say the formula is actually is volume equals 4 over 3 pi r cubed. Okay. So what I'm gonna do is I'm gonna show you. Okay. Uh, I'm gonna show you the formula, which is equals basing on the formula above. Okay, this one, and that would be 4 over 3. Right, 4 over 3 multiplied by pi. Don't forget the parentheses because that would give you the pi, and then multiplication multiply by again. Now we'll be able to use the power. Okay, so the power is the base number and the power number. So the base would be from this range A56 comma, and since our formula is cube, volume is 4 over 3 pi r cube, radius cube. So that would be 3 here. Then close it, then you got your volume of a sphere. Okay. So now I'm gonna show you the formula. I'm gonna put a single quotation mark here. Then there's your formula. Okay, another example I'm gonna give you using again the power is formula. Calculate the compound interest. Okay, what I had here was the compound growth over years. No, we're able to get the compounded growth sales by having the sales, having the years, and the growth in terms of interest. Okay. So what I'm having here is calculate the compound interest. So the formula is equals to A equals P. Inside the parenthesis is 1 plus R or interest over 9, or rather, sorry, over N, closing parenthesis, then raised to the power of NT, then close parenthesis. Okay. So I'm going to give you the meaning. P is equal to principal, which is the initial investment, and R is interest rate, N is number of times interest is compounded per period, T is equal to the time money is invested for in years, and A is amount of money accumulated after interest. So what I got here is the data set having the principal amount, then the interest rate of the, in terms of 3% interest rate, 4%, 5%. Then compounds per year was 4 to 12, and the years, the period is 3, 5, 3, 10. What I'm gonna do is I'm gonna get the amount, the accumulated amount using that formula above. What is A amount? We're gonna get the amount, and then equals to P, that formula. We're gonna follow that formula. So therefore, what I'm gonna do is I'm gonna follow this formula. So the first one, based on this formula, okay, based on the above formula, which I've shown you, is equals to A73. So I'm gonna put A. Let me check. Okay, A73. So A73. All right. A73. Now I'm gonna multiply it by power. All right. Power is inside the parenthesis is 1. Okay, plus B74. What is B74? This one, B74. No, not B74. B73 rather, sorry. B73, B73. Okay. What else? B73 divided by uh, C73, which is the compounds per year. Okay. Then comma, and then C73. Okay, again. Sorry, C73 again. This one. And then I'm going to multiply this by C74 as rather D73, which is the years. Okay, that's it. Then I'm going to close it. Okay, you got it. A73 is the principal amount. Okay, multiplied by the power function. Inside the parenthesis is 1 plus B. What is B? B is compounds per year, and then divided by C, column C, which is compounds per year, multiplied by D, which is the years. Okay. Okay. Then how many open parentheses we have? 1, 2, 2. Therefore, I'm gonna need one more parenthesis here, because the open parenthesis and the closing parenthesis should be equal. Enter. Right. What happened? Okay. Just one. Just one open. Sorry. Okay. So the answer is 12,820. That would be accumulated amount. So the accumulated amount is um, a column, the principal amount. Okay, the accumulated amount is the principal amount, or rather the right the the present value rather, sorry, present value, okay, or the principal amount. Uh, Multiply by power function, okay, 1 plus b. B is the interest rate, and divided by C, which is the compounds per year, okay, comma, compounds per year, multiply by D, which is the years, okay, and enter. Okay, that's why I got 12,820. Okay, but the principal is only 10,000, but the accumulated amount is 12,000. Okay, over the years. I'm just gonna, copy it down. Then I'm gonna put a single quotation mark for you to be able to see the entire, sorry, the entire equation or the formula. All right. All right. Okay. So that's how you're gonna, how you're gonna use the power function and giving all these example that I have given to you. So that's it for today, and thank you for watching. See you next time.